Alright guys, welcome back to the another video. In this video, I'm going to show you how to create the land use land cover map like this, which is the Pokhara region with 7 classes. And of course, if I like reduce the opacity, it's quite perfectly matching with the Sentinel-2 imagery. So if you want to know how did I create this map, watch this video till the end. So let's get started. All right, so first thing first, in most of my video I try to create the outline first, and then after that I'll add the code and explain it, and then show you uh, how to do the accuracy assessment and how to do the other additional things. So here in this easy 5 steps, so I'll show you like how to create the land use land cover map with 7 different classes, and also I'll show you how to do the accuracy assessment. And most importantly, uh, I have seen lots of tutorial, they talk very less about like creating training dataset. In this particular tutorial I'm going to talk focus more on like creating training dataset, how to create the good training dataset, and what to include and what not to. So yeah, this is my outline. First thing first, so I'm going to like select the imagery. For that I'll select Sentinel-2, or maybe the harmonize. I can directly search like that. So basically the purpose of selecting harmonized Sentinel-2 MSI dataset is since it's available from 2015, and then it's the radiometric corrected dataset, and also after 2022, so they have some changes on their sensor, so it automatically adjusts that new value, and then it particularly very useful uh, for the land use land cover analysis. So basically I'm simply going to import this data set and then filter it based on my need. So maybe I can paste some code over here and then try to explain. So first of all, I am selecting this data set, and of course you can select whatever date you want, and maybe based on seasonal variation your data set might your imagery might change a lot, right? So for me I'm selecting this autumn month from like October to December, which has very clear view, particularly in Nepal. And then I'm also filtering like cloud pixel percentage of 20. So if the cloud is more than 20%, so I simply this script simply ignore that. And then filter bound to AOI. So here I need to create the area of interest as well, right? So for example, here I'm going to create the area of interest, something like this, and then I'll write this is AOI, and this is my area of interest, right? And then here I need this max as to cloud function. In most of my tutorial I have shown you like how to write this function, basically what bands to select. So I'm not going to spend too much time, but the thing is using this function we can like max the cloud. And then of course for the QA there is the band name is QA60, and then bits 10 and 11 are cloud and cirrus. That's why we are filtering that. We are creating the uh, max layer with like either cloud or cirrus, cloud and cirrus, and then we update that max and then divide. This is just the scale factor. So basically if I check the imagery, so here we have QA60 bitmax function, right? And then 10 is the opaque cloud, and then 11 is cirrus cloud. That's why we are filtering that band, right? So basically you can put all the like function at the below part. Normally that's what I try to like try to write. And then here I max out the cloud, and then I map all the images and then clip all the images to area of interest, and I take the median value of all the imagery. And basically in order to like select the band, so here I'm also going to write that function select bands, and then it will take the imagery, and then it should be, for now simply it will return the imagery dot select, and then the bands. Maybe I can write whatever bands I need. For example, in case of Sentinel-2, I might need the RGB NIR band is band 8, and then SWIR1 and SWIR2. These are the essential band, right? And then here I can return simply the bands, right? The required bands. So basically this function will select the required bands, and then if I print imagery, so if I run it, then I'll get all six band from like this median imagery. So 4, 3, 2, 8, 11, and 12, right? And it's always like better to like visualize and see what this imagery looks like. And for that, for now I'm simply going to put the imagery, and then visualization parameter is null, I mean simply empty, and then this is the name of imagery, and by default it won't be loaded. So if I run it, so I will get this, and maybe I can remove this, and by default your imagery will look like this black, right? This is due to simply visualization parameter based on bit depth. So basically in order to visualize it properly, normally I try to stretch it by 98 percentile, but of course we can like use the 1 sigma, 2 sigma, or 3 sigma function. These are also good, better visualization parameters. So yeah, after that I normally import these. So if I import these, it will be available on the top. Sorry, I imported twice. So after that I can simply say RGB base param, right? And then I can, sorry, I need to write it somewhere here. RGB b, okay, this is the name, so simply hit run. Oh sorry, RGB bis pra, sorry, it should be bis. Okay, so if I do that, then normally my imagery will load in the same visualization parameter, and maybe I can set it to true, so that each time whenever I run the function, so I get the imagery. All right, so this is the first step. It's about simply selecting imagery and filtering the required bands, or like filtering based on cloud or the area of interest, right? And now the second step is to like create the training data set. Of course, we are going to create the data set within this GE portal. So in order to do that, so first of all you need to like create the new layer, and then maybe for the new layer you can say whatever class you want to create, right? And for now I would say vegetation, and then we need to change it to feature collection. And in the property I think we need to write class equal to 1. So that means the vegetation class we are going to create, it's the class 1. It's the first class we have, and then don't forget to change this import is statement to the feature collection. And don't worry about this simply colors, so it doesn't matter much. And then whenever you try to create the like samples, normally I do like this. So maybe I can create the triangle with like very small triangles. Don't create too big one samples, because for the resident area we'll be creating very small samples, right? And then of course this is also like dense vegetation area, so basically like this. And then you need to include as much variation as possible. For example, those were dense vegetation, right? And this seems a little bit different in color, so we need to include this to the data set as well, and then these to the data set as well, right? And of course the other thing is like, for example, here it seems like it's not that much dense vegetation, so for that also you need to like create your training sample. And for this shadow part also, this might be vegetation or this might be water, right? Since we are confused, that's why it's better to always visualize this image in different setting, right? For example, this is 832, this is the false color composite. And normally if the area reflect the red light, red color, then it's the vegetation. And if it reflect the black color, it might not be the vegetation, so looks like it might not be the vegetation. For example, in case of like lakes, so this is particularly different color, right? Blue color or the black color, so it's definitely the water bodies. And yeah, this way we can simply filter out the like whichever like whichever vegetated area we want to map. And then of course the red area, since the red area, more red area is the vegetated area, so we need to create the training sample like this. All right, so the another thing, another easy way to like digitize is the water bodies. I'm going to select that as water, and then feature collection, and maybe class to 2. And of course these two are known lakes, so I know these are definitely water bodies, so I'm going to create the water sample. So basically click like this, and oh, okay. So and after that we move to the other lake. This is also water. Sorry, maybe I need to zoom in. And this water is a little bit slightly different than the other one, so we also need to digitize this. And maybe in that case you can zoom in more. And normally this boundary pixel, which has both reflectance value of like water and maybe the vegetation, so it might create an issue. So for that also, maybe you can either include these pixels into vegetation or in the water bodies. So basically, or your model will automatically determine which category it belongs to. So basically I'm saying that these are also my water bodies. And the thing not to forget is like, we take the sample from most of the lakes, right? But don't forget to take the sample from actual river, right? So this is the river, and then if you don't take the sample from river, your model might not know like which, I mean, what to do with this kind of pixel, because the water reflectance value from lake is very different from the reflectance value from like river. So yeah, you can create the sample like this. Sorry, I need to zoom in more. And yeah, this is also the easy task, right? And the other thing I would like to add here is like actually on the select band function. So I want to replace this function with the other function, so that it will be very easier for us to like see the other kind of properties. For example, in the function select band function. Okay, so in this function, so we calculate the ndvi. If you know ndvi means, that means like it's normalized different base station index. Higher the value of ndvi, that means higher the vegetated area, right? And then it's nir minus rate by nir plus rate, so we calculate that. And then ndbi, so basically it's the build up index, and the formula is swir minus nir by swir plus uh, nir, and it's modified normalized different water index. So basically the formula is green minus swir1 divided by green plus swir1. So basically higher the value, that means it's the water body, and lower the value, that means it might be either built up or the vegetated area. And I'm adding another band as well. It's not that popular one, normalized differential sandy land index, and the formula is rate minus swir1 divided by rate plus swir1. The reason I'm computing this band is computing this normalized index is like, since the sand in our build up area mostly reflect the similar reflectance value, and sometimes it might, our model might get confused with whether it's sand or whether it's built up area. That's why I'm simply computing this band as well. And then we are selecting the previous bands, right? And then we are also adding the new bands to our actual imagery, which is ndvi, mn, dwi, ndvi, and ndsli. If I hit run, so I'll see the 10 more bands, right? So now, for example, in order to digitize the vegetated area, so basically we can select the ndvi and then apply, or maybe again calculate the 98th percentile and then apply and then close. So basically based on this, the red most area are the vegetated area, right? And then if you want to digitize the water, then you can simply select m and dwi, and then maybe also you need to like calculate the 98th percentile and then click ok and then close. So basically here the red area represent the water, and then maybe this kind of red palette represent the like some sort of moisture area. So you don't need to digitize those, but definitely this is water, this is water, and then we are seeing some of the water over this river as well, right? And then these are just the like errors. I mean, these are not the not the actual water, but maybe the moisture. And for example, if you have to digitize the built up area, then you can select ndbi, which is built up index, and then apply it, and then maybe based on this zoom level we compute again 98th percentile and then apply it and then close it. And then this region is the actual built up area, right? Now from this red things, you can simply select the built up area. For example, I need to create the another class named as built up, and then I can select the feature collection, and here I need to select the red area. If you want to see the base map, which is satellite map, you can also do like toggle on and off and see what are the actual reflectance value. Of course, this satellite imagery is the latest one, and then I'm using also the 2023, which is also kind of latest one, so not that old. Or if you think it's still more confusing, then you can go back to the like actual band combination, which is 432. This is your like true color composite, right? And then with this, it might be like sometime easier to like digitize. But when digitizing built up area, you can create very small polygons, like for example, this is definitely built up area, right? And then the reason for creating small polygons is like no, normally if you create the larger polygon, for example, I'm going to create the larger, since it's the built up area. So for example, if I create this large polygon, then this area is still vegetated area, the less dense, I mean this might be some tree, and then there might be other land classes, land cover classes, right? This sample will automatically like take the sample of like vegetated area is a built up area. That's why we to reduce that is error, so we try to create the small like polygons. For example, this polygon, I'm going to delete it. And then another another thing is, just try to select it as many reflectance value or as many different colors as possible, but make sure that's your built up area, right? For example, this one. And the another thing is, for example, here is our airport, right? This is also built up area, but the thing is, in this built up area we have some sort of like grasses or the vegetated area between this built up area. That's why you should ignore that and then simply consider this as a built up area, maybe this one, right? Like this. And then maybe this is also like very dense built up area, so make sure to create very small polygons to reduce the error, right? And then for the like cultivation area, maybe you can select this land, or maybe some of the like these lands, because this is also the cultivation area. When I check in like main, like our main satellite imagery, so these are also cultivation area, so make sure to like get reference from satellite imagery as well. And then just create your create your like polygons. And the other thing is, sometime people might create the polygon outside our imagery. For example, if I create polygon somewhere here, then this is not inside my polygon, right, actual area of interest. That's why this might also create an issue. So make sure to select the appropriate like polygons, appropriate amount of polygons. Yeah. So now with the select band, actually, so we are applying like 10 bands from we are going to like train our model on 10 bands. All right, so I hope in this similar way you can create whatever class you want to cover up your study area, and then make sure to like digitize this cloud as well, and then write in the class name is other or cloud, and then try to train that as well, right? So yeah, that's all about like creating data set. But after that, we need to like do some few steps to actually convert these polygons into the actual raster imagery, because in the model, while training the machine learning model, we need raster values, right, pixel values to train our model. All right. So from now on, I just switch my previous code. So here I'm going to explain like what I'm doing. So basically, first I create all the like samples. So if you want to see how many samples I created, so this is the number of samples. So for water, I have 28 samples, vegetation 13 polygons, and then cultivation 21, built up 15, and so on, right? And there are 7 different class, and I also try to distinguish, separate the urban area from sand, because if you don't separate that, in most of the Nepali rivers, most of the like Nepali area, for example, this particular region is sandy area, right? If you did not separate that, then definitely this is going to be your part of built up area, and then your model will compute this sandy area is a built up area, because reflectance value from like road or the this airport will be same as the river sand, right? So that's why I separated sand as well, and then bare land, which means very like unused land. And as I said before, in order to digitize those samples, so I try to select the different band here, and then try to like digitize based on that band, right? And the thing is, after like completing digitization, so you'll see all your like classes at the top of the import bar, right? And after that, if you want to like, you have to like merge all the samples into the one variable. For example, here I have the sample variable, and I'm merging like water with cultivation, vegetation, built up, cloud, sand, bear, and then I create the random column on all the like samples, right? Basically, this code will automatically merge all the polygons. I mean, it will create the one simple feature layer which has all the values. And then this, to distinguish water from cultivation or water from vegetation, we have this class value, right? So for example, here in the water we have class and equal to value equal to 3, right? This will distinguish the different classes. And now the in the next step, we need to like separate the split the train and test data set. So basically the training data set will be used to train our model. So basically, in the simpler term, so basically your model will try to memorize these things from training data set, and the test data set is used to calculate your accuracy metric. Basically, this is on-scene data set from model, and then this on-scene data will be used to calculate the model to to evaluate your model, right? And in the next step, we need to actually like extract the image values. So basically, imagery dot sample regions, so this function will take the like sample from that particular polygon. For example, in case of training sets, our scale is 10 meter, since it's the Sentinel-2 model, and then property is the based on class we are trying to categorize it, right? And then the in the test sample, so we have also the imagery dot sample region, and then we have test sample with 10 scale, and then class property, right? And then this is my legend. So basically, whatever you are seeing here, this different color and classes, so this is the actual palette to generate this legend. Sorry, not to generate the legend. I have different code in the UI block down below, but this is the simple like legend. So value 1 means this color, value 2 means this color, and so on. And in order to like train the model, so we need to check the EE classifier, and then whatever function or whatever like machine learning model you want. So if you want to know more about this, so basically you can search here classifier, right? And then inside classifier, so basically you will see lots of models. So these all are like different model. For example, some of the common one, most popular one are decision tree and live SVM, and then smiley KNN, and then random forest. So these are all the metrics. So feel free to test all the like models. Basically, you just need to replace this function name, and then maybe sometime you need to pass the number of nodes or the one parameter, and sometime this will be your default. I mean, most of the model have their own default value. So here I'm training based on random forest model, and then of course dot train. So since I'm going to train it based on my training sample, and then the property will be the class, and then my bands will be the imagery dot bands name. So basically it will print out the whatever band we selected, for example this band and then these band, right? So this all band I'm using to train my model. So if you want to know more, maybe you can write like train, and then in the train function, right? Here you can read about all the things like what are the parameters I need, and then how to train my model. So basically feature will be the our like samples, and then class property is the property based on which we are trying to classify, and then input properties, that means the number of bands, right? So it's the list, and then other things are like minor things, you can simply ignore that. And yeah, this is my model. So yeah, basically in GE, Google Earth Engine, it's very easy. Within one line of code you can create model, and then of course if you want to create the another model, for example SVM, then you can simply write lib SVM, and then you can check the parameter, and then here decision procedure is voting, right? So maybe you can leave the parameter, so default parameter, right? So I'm not going to change to leave SPM, so I'll simply set it as Ismail random forest. And yeah, this is the way of like selecting your training model, right? And then for the accuracy testing actually, so this is our fifth step. So basically it's also the one line of code. So basically for the confusion matrix, so we rely on test sample, and then we try to classify our model based on the RF model, and then we call it as predict, and then we like show the error matrix as class, and then predict value, right? And then sorry, and we simply print that like confusion matrix in the like console chart over here. And also for the like classification, so we use LULC equal to since we have imagery, we have samples. Now based on that, we are going to like classify land use land cover classes of this each pixels from this whole imagery, right? So in order to do that, simply we can follow the similar procedure is above. So imagery dot classify based on this model, and the name it is LULC, and then we set the legend to whatever we have over here, right? Simply it's just to map the color, and we add that to the map. So basically if we run this code, so basically we'll get the image with like 10 different bands, right? All the like NDVI, MNDWI, this computed band as well as our original band. And then we also got the confusion matrix. So basically in the confusion matrix, so we have like zero class. Since we don't have any zero class, that's why all the value are zero. And then 74, that means it's computed all the like all the samples correctly, and 2 also it computed all the sample correctly, 3 computed correctly, 4 it has some issue with the fourth class, which is 1 2 3 4 2, which is R1, right? In R1 it has like almost most of the sample classified is correctly, but some of them are like some of them has issue. And the fifth also quite good, sixth also quite good. But for the bare land, it confused with the cultivation or the water, 1 2 3, that means water. Oh, it should be the cultivation because we don't have zero. So basically the bare land is confused with the cultivation land because in the non-growing period month, so the basically bare land looks like the cultivation land, that's why it get confused. Overall our accuracy is 84% and the kappa coefficient is 80%, which is quite good for this model. And then this thing we can also like verify by like simply swiping this LULC. Or maybe I need to toggle this dataset RGB. And then here you can see clearly our water is classified almost correctly, and then also the built up area is quite correct. And these are the bare land, right? And then if I zoom in here, so yeah, it's very sometimes it's quite difficult to classify bear and then the actual agricultural land, that's why our model get confused, it has some issue. And also as I said before, we have some issue with the sand, right? So for example, this is the sandy area but it classify as the built up area, and this is the common issue. And I also don't have better solution in order to distinguish sand and build up area. If you have any suggestion, let me know in the comment section. So yeah, this is our land use land cover map. Another minor thing to discuss would be like creating the legend. This legend can be created using this UI.panel property, and if you are unsure about that, then make sure to check this example site, and it has lots of like examples with like how to create chart and then how to like create the UI, mobile friendly UI, and lots of things, right? So basically this is the reference for creating UI. So here I'm using UI panel, and then I put the position is bottom left, and then this is padding, and then this is the legend title, right? And then I added that legend to legend title. And then for the making row, so basically I'm calculating the colors, and then these colors from legend, and then I add the name description, right? And I add that to the UI, and then based on my palette and names, so I use the for loop to create this legend. So that's all about like creating legend. And the final step it is to like export this image, this LULC land use land cover image, to your Google Drive. So in order to do that, you can write like this. So the export image to drive, and then our image will be the LULC, which is this map, and then scale will be 10 meter, and then region is of course AOI, our area of interest, and CRS is this maximum pixel is set because otherwise you might encounter a memory issue. And then this is the folder name in your Google Drive, and then destination uh, description will be LULC plus year, or maybe LULC 2023 Pokhara. And then format option, of course this is optional. So this if you want to export it as cloud optimized geotip, so make sure to turn it in. So yeah, that's all. So if you run it, so after a few seconds you'll see something in the task bar. So this is LULC 2023, right? If you hit run, then it will ask for the additional things. And this is the file name is LULC23 Pokhara, and then this is folder, and then this is GeoDev. Hit run, and then you can download it from Google Drive. So yeah, that's all easy step. All right, so that's all about creating LULC. Oh, sorry, one thing I forgot to mention is like creating this training data set. Actually, this is the iterative process. So, for example, I have only 50 polygons it first, and then whenever I try to compute the land use land cover map, most of my area was either covered with the vegetated area and or the like built up area. And in that case, I have to like zoom into the particular section which might have misclassified, and then I need to like manually correct those. For example, in my first run, this this area might be like classified as a built up area, right? And then in that case, so I can simply select cultivation area and then created these polygon, right? So basically in the initial run, these area were classified as built up area. So uh, I simply run it. I mean, I simply created another polygon with cultivation area because I know these are cultivation area. And after I run it, so I simply exclude those from like built up area. So basically, in case of misclassification, you need to like iterate it and then correct the samples again and again to actually get the better results. So yeah, so that's all about this video. I hope you enjoyed it, and I hope I make the most of the things clear, particularly about how to create the training dataset for your machine learning model. So I'll see you in next